So I talked yesterday about how you can design things in Castle Game Engine editor and then display them in like a dedicated Castle Game Engine window, okay? Now, there's more actually what you can do. I mean, you can, in particular, you can just drop Castle Game Engine control on a FireMonkey or VCL form, and then the engine can take care of rendering 3D or 2D stuff, whatever you want, some interactions, some animations, and so on. And yeah, you can kind of surround it with everything else that you already know from FireMonkey or VCL. And let's just see a demo of it. So this is a kind of regular FireMonkey application, kind of, I guess, the simplest one. And there's the control. It's called T-Castle control. It's a new control registered on the Delphi component palette. It's down here. Yeah, and I just dropped it on the form. As you can see at the design time in the Delphi IDE, I don't actually see anything. That's kind of a limitation of the FireMonkey because I cannot get a native handle at the design time that actually works. Long story short. Yeah, but if I run the application, it will just work in the sense that there's Castle Game Engine rendering inside the Delphi FireMonkey form. There was the physics simulation. I can use my mouse to rotate around. I can switch to two-dimensional view. I can show some UI, which in this case is a bit dummy, but yeah, it works. So yeah. Underneath the source code of it is kind of trivial. I mean, I'm not really doing here anything involved. I just have this T-Castle control component, and inside of it, well, I can plug anything I want. Let me actually show you the simpler one, okay? Because then I wouldn't be doing a good job if I would be telling you that this is the simplest version. Right? So let's take even a simplest version. This one, this one, this one. No. Right. So this is even simplest, okay? Simpler, okay? So let me run it. Let me compile it.
Component must be registered, or there is a sort kind of installation procedure?
You just have to, yeah, you just install the package in Delphi, and that's it. There's no special installation procedure right now, and I know why this happened. That's because I want to show you something in a second. That's all good. Okay, so that's, I guess, a very, very simple Castle Game Engine application running in a FireMonkey using some two FireMonkey buttons. What it's doing is that every time I click a button, I spawn a bunny or this weird thing called Dino, okay? And really the point of it is that the code of it is very, very simple, okay? So I can assign something to the form create, so the event on create event on the form, a regular event on the FireMonkey form, and there I can create some Castle Game Engine controls. Here I'm creating the viewport, which is like your window to view your three-dimensional scene. And then inside of it, I'm setting up some camera to look at something particular. I'm setting up some light so that things are lit. And then each time you press a button, I instantiate and I create a new instance of a class T-Castle scene. And inside of this, I load the dino.gltf model. And I randomize its position, okay? Translation is essentially random, that's the point of it. Oh, and I also run some animation of it, because why not? And then I'm adding it to the viewport to actually display it. So the point of it is that it's like, I mean, everything that you saw on the yesterday also would work here. Now it's just inside the FireMonkey application, inside the FireMonkey form, and it's kind of easy, okay? And then another thing, I guess, important point I want to make is that in this case, I have actually not used the Castle Game Engine editor at all, okay? Like I have instantiated this viewport and the scene completely using my own Pascal code. But it's like my choice. So I can use the editor to design my visual stuff, maybe part of it, maybe all of it, maybe none of it. So I don't have to use the editor to design my stuff. But I can. And it's an independent choice whether I'm actually rendering using our dedicated window control or whether I'm using our rendering that puts our stuff inside an existing FireMonkey or VCL application. So in both those cases, I can design some things using the editor or not. In particular, like this demo, let's get it. So in particular, like this demo, you saw how it showed the physics running, yeah? And this one I actually didn't write from code because, well, that would be too much work, I guess. So yeah, so this looks nice, yeah? But I didn't write any code in it to actually make it happen. The way it happens is that there is a design done in a very similar way as you saw yesterday. So I can open this project and let me go to the examples, Delphi FMX. Okay. And there's the data and there's the 3D user interface. Okay. So this is something I have designed using Castle Game Engine Editor, and that's okay. I can still connect it I can load it into something that is displayed inside your FireMonkey or VCL application. I'm speaking so much about FireMonkey and VCL, so let me just make, I guess, a quick proof that I'm not lying in the sense that, all right, let me open a VCL application too, and there's no surprises, the code is very similar. Everything I've shown here, it just works the same in VCL. Okay, I will just very quickly just blink you with it, okay? Because there's some different two-dimensional animation loaded there, but the approach is all the same, okay? You just drop the T-Castle control component on a form, and yeah, the engine just is rendering everything. Let's not wait. Can I do it? No? Okay, who knows what happened now?
Excuse me, you use the 64-bit platform.
Windows 64, yeah.
Yeah, for Windows. You also can use 32?
Of course. I'm kind of used to using testing on 64-bit by default now. I know that in Delphi, like Delphi IDE is still 32-bit, so of course we support 32-bit for everything. But I'm kind of used to testing everything on 64-bit because at this point it's more what users even expect. So like they make like weird faces, really, Windows 32? And we know that it's actually okay, pretty much everything works, yeah. But users kind of even expect it's 64. Why it's compiling so long, I don't know, but it's the same example. You can just take my word on this at this point. No? So let me just... let's hope it dies, okay, by itself. Let me just skip to the next, to the related thing that I wanted to show at this point. That I mentioned yesterday that we also support the Linux platform. And yeah, so let me just switch the branch of Castle Game Engine to something that actually supports Linux. It's not merged into the master yet. And what is here? Going on. So Delphi is trying to do something. Excuse me for a second. If the leave demo will not work, then I guess I will cancel it. Okay, I have no idea what this error actually means, and I suspect because okay, the Delphi compiler maybe still like held this file locked, something like this. Let's kill everything. Okay. So now we are on a branch that actually supports the Linux platform, and let's restart Delphi. And let me just show you that you can just switch the platform of the application to the Linux, and it will actually work. How am I going to demonstrate it? Well, underneath I'm running Windows subsystem for Linux, which is actually a very cool way to run Linux application when you have to also use Windows, because it's literally a very lightweight virtual machine that runs inside Windows. The Windows kernel kind of pretends that it can also be a Linux kernel. So it's a very efficient way to run Linux applications on Windows. And yeah, it's really comfortable to use and comfortable to start. So underneath, I mean, I'm not lying, this is just a regular Ubuntu simulated by Microsoft, by Windows at this point, okay? So let me open pretty much any application. Let's actually go with this one. Okay, so I could load this application on Windows, or let me actually open the application that I had a second ago. So this one, okay? So let me just switch the platform to Linux 64-bit, and let me press F9, and let me this time let it run. The one thing that you also want to do when you're deploying the Linux application from Windows is that you want to expose something called PA server. So that's something like this in the Embarcadero, which is basically exposing a port inside your Linux machine to which the Delphi from your Windows can connect, okay? So now once it will actually finish compiling, it will just run, okay? You will not even see much of the difference because the application just looks the same, but you will have to kind of believe me that this time it will actually be a native Linux application. If I would have a separate machine running Linux, it will like run there perfectly too. Okay, let's just wait a bit. I'm afraid to cancel stuff, okay, sorry. And by the way, also the thing that we take care about is that there's something called deployment in case of you running stuff using the PA server. Deploying, it means that when you run the application on a separate machine, possibly on a separate machine, the Delphi needs to, well, usually it needs to copy some data files from your host machine, so Windows, to your target machine, so Linux in this case. And so we have actually set up automatic generation of those deployment options in Delphi. What they mean is that if you go to the project deployment, it actually says that if you run the application on Linux or anywhere else that isn't Windows actually, please copy all those files to that machine, okay? And this is just all your data files. So that's a lot because I just have a lot of testing stuff here, yeah? But it doesn't have to be a lot if you start from one file, then it will be just one file. Okay, and as I said, like it looks the same, yeah? But you can kind of have to believe me that now it's a regular Linux application. This is the OpenGL inside of Linux. It's kind of simulated to be more or less efficient. And so it's the same application, but now running on Linux and it works. And underneath it's using also of course it's using FireMonkey, and like FireMonkey is of course our gateway to be cross-platform on Windows, on Delphi, sorry. And of course this means that like we have open window to support it to macOS, Android, iOS, and yeah, because we are basing everything on the FireMonkey. Okay, so I hope that was okay. I showed the VCL. All right. I talked about this. Okay, there's the documentation. Okay, I talked a lot. Okay, so that was like, I guess, the first thing, not really advanced, but the thing that I don't get time usually to talk about. The second thing I wanted to talk about is the building or modifying the 3D worlds. So the thing is that so far, most or maybe all of my presentations, you saw that I'm just loading some ready models. Is this like loud enough, or am I speaking to the microphone? No, I'm. Okay, so better. No. Okay, so I wanted to go with a joke, but I will stop. So yeah, so now the thing is that I don't actually have to run a ready generated model from Blender here. I don't have to run load GLTF or X3D. I can also build something myself. Underneath the engine is using something called the X3D standard, which is basically a way of exposing a lot of graphic capabilities like materials, textures, multi-texturing, cube map texturing, shaders. So it's a way of exposing all those capabilities using something called X3D nodes. And also interactions, by the way, animations. Yeah, so pretty much everything that you come to think when you think about 3D modeling or even just game data. So pretty much everything there can be expressed using something called X3D node. And what happens when we load the model from X3D format or from GLTF format, we kind of express everything we have there using X3D nodes. Now, why is this important? Because generally it's not. You don't need to care about it. But it is important if you want to build your model from scratch. Because now the important information is that everything that we load, everything we set up, from X3D, GLTF, Collada, STL, sprite sheets, and some other formats, everything of this you can construct yourself using any algorithm you want. You can make some maze, you can make some procedural terrain. Well, we made it already, but okay, you can make more advanced stuff than we have like available out of the box in Castle Game Engine. So you can do procedural generation of stuff, and this has a business application also, of course. Yes, so if you want, for example, visualize some machinery that your client is building, or maybe your client is operating, and you want to display some statistic of it, some labels overlay on top of it. Well, you can, because all of this inside, everything that you've seen so far, rendered using Castle Game Engine, everything there was actually X3D nodes, and you can construct them yourself and express everything you want, all right? I don't have a specific, I mean, I do have some code demo of it, but it's kind of, well, the code of it is it's boring, essentially. I mean, because it's like, you know, take a number of coordinates, put them into a mesh, render, and you're done. So instead, I just will run a demo, a ready demo of this approach. This is actually implemented by Eugene Loza, a long-time contributor to the engine. He's made a lot of great stuff, basically. And let me just see why it doesn't go full screen. Okay, it's full screen now. So I know it's very fast. This is the developer playing his own game. That's how it looks, I guess. And then it's also running at, I think, 3 or 10 times the speed. Now, the point of it is that it's a mazer game. So this labyrinth that you see that somebody is walking through, it's generated at runtime. Each time you run the game, it will be a different labyrinth. And as you can see, like, things change, like, so you have corridors, you can go up, down, you have some placeholders where you can place like cupboards, desks, and so on. You have some stairs. Oh, there are stairs. The stairs have blinked for a second there in that video. Yeah, the textures change, you can manipulate lights, everything, and etc. Okay, I guess I kind of got my point in the sense that you can completely generate your three-dimensional world using any algorithm you want and achieve something cool. In this case, a mazer game where you travel through a maze, and every time it's different. Yeah, it's just generated. Okay. So that was actually my demo of this feature. As I said, the source code is essentially, well, pick your algorithm, and the algorithm is interesting, but how to do it in the engine, it's not. You just instantiate the meshes, okay? So you can look up in the documentation. Just to expand on some possibilities of this, okay? So you can start your procedural generation, well, from nothing, okay? So just create initial boxes, spheres, meshes, whatever, or you can start from some imported model. For example, from X3D, GLTF, Collada, and so on. And you can modify it, you can tweak it. You can also compose your model, your world, from a multiple models that are transformed, meshed, I don't know, cut partially, however you want. So you can process all this X3D graph. Yeah, then you can do what you want with those nodes because you just have them in memory. So you can render them, you can process animations, and so on. And finally, at the end, if you really want to save them to disk, then yeah, you also can. You can save them to the X3D file. So X3D, I was talking a lot about X3D nodes. So that's like essentially a format for this thing in memory. But as you can guess, you can save those nodes into an X3D file. And that's a perfectly like no loss operation because it has been designed exactly to be able to serialize, a fancy word, and save to file the nodes so that you can later read them back and get the same result. And as you can see at the bottom, coming soon, we also plan to write GLTF files because GLTF is a very popular and very good standard, so we want to go more into it. Okay, so let's go into the third feature that I wanted to talk about. So that's shader effects, okay? So the idea is that the graphic cards, all since 20 years or more, so the graphic cards give you the capability to write programs that execute on the graphic card. What can this program do? Well, first of all, it can do some work for each vertex. Vertex is like a corner of the thing in your three-dimensional world. So, for example, it can shift your vertexes, maybe explode and maybe create more vertexes. That's geometry shader. So you can use those things. And then finally, the shader determines what to actually draw at each pixel of the screen. So the shader can say, for example, oh, let's do the standard lighting calculation, let's apply some texture, and we're done. But okay, that's built in, yeah, but you can do more. The shader can tell, for example, let me take a texture that represents some noise in 3D space. What does it mean? It just means that I have a texture. Well, you know, usually when you think of texture, it's an image, yeah? So it's a two-dimensional image. But you can also think that a texture is just an array, and array can be three-dimensional. So it's a three-dimensional array of data. What is the data? Well, let's imagine that, for example, each voxel, in this case, so each piece of this three-dimensional texture, it represents how dense is the fog at this point, okay? So if the fog is dense at this point, then the texture contains 1. If the fog is not dense, doesn't exist at that point, then the texture contains 0, okay? So that's kind of thing that the shader can like consume and process. Why? Well, it can then render, for example, this volumetric fog efficiently. Because what does it mean to render such, volumetric fog? Volumetric fog is basically a way, I think of smoke, yeah? A smoke coming from the ground going up, yeah? So it's like, it has this funny, not funny, but interesting density, yeah? So there's like density of stuff going up, going up, going up. So that's essentially a 3D texture that you're just sampling in a smart way. So you're sampling different layers of it. And then when you render a pixel, you wonder how much density is blocked between my eye and the thing, for example, on the roof that I'm viewing, okay? If there's a lot of density, then what I'm seeing is not really the color of the roof. I'm seeing the color of the smoke or the fog, okay? So that's, okay, I went deeper here than I wanted to, but I hope that was useful in the sense that that's one of the things that the shader can actually do. And we have an approach how to actually write shaders in our game engine that is, I think, kind of efficient and also very flexible. If you think about Unity, for example, Unity has something called surface shaders. So the idea, because, okay, now so I have described to you like the possibilities, yeah? Fog, fire, whatever you want, pretty, okay? Now the problem of actually achieving this using shaders is that when you start to use shaders, well, you need to actually implement everything yourself from scratch. So for example, maybe you want to add a fog, but yeah, you also need to implement lighting because like it's not built in the shader how to make lighting. You have to also make lighting and then you can add your fog equation on top of it, okay? And so you need the surface shaders, solve it in a way that is nice. I think we actually have a solution that is even better because we allow you to write some snippets of shading programming language using OpenGL shading programming language. And those snippets, they like have a specific plugs. You can say that they are connect to specific sockets inside a bigger shader code. And this way, you can actually enhance the look of your world by specifying multiple effects at once. For example, you can say that this is water, this is fog, this is on fire, and this is both fog and water and on fire, okay? So you can like do something like this. Let's switch to the actual demo. So I have actually 3 things to show here. So one is the volumetric fog, and then the water, and then we also have screen effects. Screen effects are the way of post-processing your screen with shaders. So the volumetric fog, this is actually doing what I was describing. So we're using so many words. So let's try to run this demo. And by the way, for this demo, I don't have any Pascal source code because there's none. You just write those shaders and then you wrap them. Okay, there's one line. You just wrap them in a special X3D file, and then in the engine you say add effect. So there's not much to do. On Pascal side, you're welcome to look at the documentation, of course. But most of the work happens in the OpenGL shading language coding, okay? So where's this fog that I was talking so much about? Okay. It's maybe, should I make it darker? Better? Maybe. Okay. By the way, this darkening was also actually an effect of our shader, okay? So this is an example of a very simple implementation of how you can make a fog that goes up. Now, I can make it better now, but this is kind of an old demo. So that's one example of it. Another demo is the demo of water. And for this, let me actually run our terrain demo from the engine. So let me close, switch project, open, terrain, okay? So another application of those shader effects is how do you do water? Well, water is actually, well, mostly 2 things. One thing is that water is like a mirror. So you need something called generated cube map that, or in this case, generated texture that captures what this mirror should display. And another thing that water is that water is moving. So it's not a flat mirror. It's a mirror that has waves, and those waves animate as time passes. Yeah. So that's a real-time mirror, and that's a water. So that's a real-time mirror and also a water. What I'm showing you right now, and it's real-time, and I'm running it in the editor just to show you that it's really real-time because I can do things. Yeah. So I can essentially like drag even this tree, and it actually like works. I mean, everything I shown here is dynamic, so it's a dynamic water effect that shows some waves. And there's a lot of configuration here, of course. How granular are those waves? How fast are they moving? And so on and so on. So this is like a ready effect that you can just tweak the parameters of. But the point here is that like the capability to design such things is available for you. And another thing, the last thing I want to show about those shader effects is also that you can use screen post-processing effects. Let me just run our one of our games in Catastrophe games that we have made a long time ago. It still is released on Nintendo Switch, and it actually uses those screen effects in some nice ways. Let me try to see can I actually play it. Okay, so you're flying with a ship. There's some story, and then look what happens when I collide. Now I suck at this game also, but this time I suck it deliberately. Okay, so look what happens when I try to collide with things. Yeah, so there's this nice effect that things go a bit blurry and something weird is going on with the colors. That's a story. Read the story. The game is better when you read the story. Okay, let me try to collide with something again. Okay. So the point here is that, well, this was supposed to be, this was, I guess, a bit of inspired by some bullet hell kind of games where there's a lot of stuff going on the screen. And the important thing here was that when there's a lot of stuff going on the screen, you also want a lot of graphic effects to happen. So the screen shakes. There's blur from time to time. And finally, there's something called chromatic aberration. So you probably was not really able to see it, but if I would make it a screenshot, then it looks like this. As you can see, I guess, especially here on the left side, or maybe here actually. Here is visible perfectly. So the chromatic aberration is something that occurs in the old broken TV screens. So it like gives you this old schooly look a bit. And the way it works is that the red and green colors, I mean the part of the spectrum which is responsible for showing you the red and green colors, it's shifted in relation to where the blue colors are visible. And that's exactly what happens here. So those are some chosen screenshots from this game. I'm glancing at the screen whether it's actually visible on the wall, but I guess it is. And the point here is that it's really easy to implement such thing in Castle Game Engine, because what do? Well, this is observed. So this is the OpenGL shading language code, to be clear. It's not Pascal, don't worry. I will like walk you through it. It's nothing special, to be honest. So the thing is, okay, screen FX is look at the horizontal position of your pixel. Now add something to it to look to the right of it, okay? And there's your position from which you want to take the red and green part of your color, okay? So now you're using this screen F get color, and you're using this red green X coordinate, okay? Okay, so we're taking the red and green component of your color from the right side of the screen. Now let's take the blue component of your color from a pixel that was actually supposed to be rendered on the left, okay? So here we take this horizontal position, we shift it to the left because we subtract something, and again we get the screen color, yeah? So initially what happens is that the engine, you don't see it, but the engine is rendering the screen in a normal way, okay, without this effect. And it gets rendered to an internal texture. And you're sampling this texture, which means that now you are rendering your final image to the screen. And you can use this initial proper image as much as you want. You can, as you can see, you can like break it by shifting some colors. And you can do a lot of interesting stuff. You can like bend the screen, you can make a swirl, and so on and so on. So those are the shader post-processing effects. Okay. Okay, I think I'm even reasonably good on time. So the fourth thing I wanted to talk about are custom components. So this actually will come as no surprise to you. Like you use Delphi IDE, you can register custom components in Delphi IDE. I even showed how to that we register some custom control component. Okay. Now the point is that you can also register specific components to be available in custom game engine editor. So like this here is like our built-in components, like some user interface, navigation, some non-visual stuff, some transformation and so on. You can define your own. And you can define them inside a specific project. So that's a bit different than, for example, you come to know from Delphi. Because in Delphi, you install a component and it's available for all your projects. Here it's a bit inverse in the sense that the project, you can do it whatever in various ways, but by default, your component, your custom components, they live inside your project. And the point is that every developer who downloads your project from, for example, version control, Git, whatever, they also can use those custom components when they will open your project in Custom Game Engine Editor. So that's a bit like Unreal Engine, essentially. Well, we are not Unreal Engine, but the mechanism is actually similar. If you use Unreal Engine, then if you want to have custom components in Unreal Engine, you could just recompile the engine and the custom components are added to the engine. And that's actually the same thing that happens in our case, in that you can recompile the engine, but it's really just one click, it's completely automated. So you can kind of recompile the engine to get your custom components visible inside, and and then you work with this custom game engine, custom game engine editor, but it's just enhanced with a few components that you've made. What can your components do? A bit whatever. There are some examples here. So for example, you can make a button that has a consistent UI. You can make a 3D object like a machinery part. And this may, for example, connect with some of the previous things. Like I said about procedural generating stuff. Okay, you can like wrap it in a custom component. Like maybe you have a valve, a pipe, or whatever. Yeah, so you can make a component like a three-dimensional pipe through which the water flows, and you can expose simple properties like the length of this pipe, like some sockets that go out of it, something like this. So you can define a component like that, and you can use this component inside Custom Game Engine Editor, so at design time too. All right. There are some examples. So like what you can do with this custom component. So of course you can do the same thing that you kind of do when you register a Delphi component. So you have component editors, you have property editors. So the component editor is what happens when you right click on something and you get some menu. Like reset transformation on this cone, where is it? Okay, so there's the cone, okay? So reset transformation is an operation that has been defined on this type of object, yeah? So you can define more such operation, okay? That's kind of trivial. Property editors are the thing that you configure what happens when you try to edit a property, okay? So like here we have a property that allows you to edit the color. And that's built in, but the point is that you can make your own property editors for your own components that do whatever you want. And finally, you can also override some specific Custom Game Engine methods that allow you to, as it says here, that allow you to kind of have specific design time behaviors for Custom Game Engine components. What does it mean? You can kind of, for example, you can kind of make a 3D or 2D authoring application inside Custom Game Engine Editor. It's a bit crazy endeavor, yeah, but maybe for a specific project, it actually makes sense. So you can design stuff in Custom Game Engine Editor this way. Now I actually wanted to show here a simple demo first. Okay, but then let me go for this, like, I guess, more impressive, a bit more impressive demo, and then I will show you how it actually works underneath, okay? So I'm now opening the project, the demo of the project called Custom Lines 2D. So basically it allows you to design polygons and lines inside Custom Game Engine Editor. It's a bit, well, it's much simpler than the typical painting application. But the point is that like we can, if we wanted to, if we were crazy enough, we could actually design, I don't know, Paint or GIMP or whatever, or maybe Blender inside Castle Game Engine. I mean, we will not. That's crazy, but we could try to do it essentially. What did I wanted to open? Oh yeah. So Castle, lines 2D, examples. I think let's start with the gallery. Let's just go with the gallery. So when I open this project, this window pops up, okay? The project gallery uses custom components, and I can rebuild and restart editor with support for those custom components. And I can click run last build. That's what I did yesterday, but let me just click yes to prove to you that I'm not lying. So we can rebuild the editor with support for those custom components, and you will see what happens. I see I should have chosen the ready build. Okay. There's a small catch here in the sense that we are at Delphi conference. The building of the custom game engine editor, it actually uses Lazarus, Free Pascal for compilation. It still completely makes sense if you develop your game in Delphi, but what it implies is that you will just have to keep part of your code base, the one where you have custom components, compatible both with Delphi and with Free Pascal compiler. If this sounds like a lot of work, it's not, in the sense that I've been doing this with all my code base in Pascal for many years. So it's not that difficult to write Pascal code that just works with both of those compilers. In the future, I will just keep talking when this goes. Yeah? So in the future, we kind of plan to change the interface of Castle Game Engine editor to also use our own user interface, which means that the Castle Game Engine editor will be designed using Castle Game Engine editor. And the point of it is that then both Delphi and Free Pascal will be able to compile Castle Game Engine, so also your custom components, and it has additional benefits, like we're thinking about going to the web platform. I mean, we're not thinking anymore. We know we're looking for opportunity in time to do it. So we know we will want to add the web platform support to our engine. And one of the things we want to do there is that it's not just about making your games available on the web, in the browser, using WebAssembly. No, we actually want to do more. We want to also expose the editor inside the browser. And if the editor will be also a regular Castle Game Engine application, then it will kind of just work. Okay. Okay, and compilation is still going, but it should finish very soon because it's already linking. Yeah, and that's it. Okay, so here you have at the top. I mean, this looks the same, yeah, but the title of the window have changed. Gallery with custom components. So now, if I open this, this doesn't look like much, yeah. But the thing is that I can select something like a line or a polygon. Yeah, let's actually go with the star, and I can turn edit mode on. And now I have, as promised, like a simple editor of polygons inside Castle Game Engine editor. And the nice thing is that like you get all those ready things from Castle Game Engine. Like, I mean, you can shift the view, you can zoom the view, the undo works, and so on and so on. Yeah. So you can like, yeah. So basically, you do have all those ready things that come just by using Castle Game Engine. So you can make things that expose some additional design time behaviors. Okay, I did also wanted to just quickly show you how to do it. Let me just do it quickly. Do not hold you. Custom component. Go on. So the way it works is that you declare a unit, and this unit has a component that descends from something in Castle Game Engine, like in this case, Castle User Interface. And that's it. Okay, that's not almost, yeah? So you call one method, register serializable component, and this tells Castle Game Engine that this component should be available inside the Castle Game Engine editor. And that's almost it, actually, because now we also need to do one other thing, which is that in the manifest, which is like our main project file, you need to tell the editor that you have some editor units, which in simple terms, it means that you have some components that enhance how the Castle Game Engine editor works. And you would like that everybody who edits this project rebuilds the editor with support for those components. And that's it. We do not have to go deeper into that source code. It's nothing very impressive there. There is more documentation. So maybe some stuff I forgot, I guess. So you can do some, you can do something like nested design. That's something that I didn't actually get to talk about yesterday. But the point here is that so far everything I've shown is like designing things that are going to be displayed like a form. Okay, so it's like a final design. But you can also have a design that is going to be reused multiple times, and you actually know it from Delphi. It's called frame. Yeah. So in Delphi you can have a frame, and it's kind of a reusable composition of components. And yeah, you have it also in Castle Game Engine, in which case it can also be a three-dimensional thing. So you can have like a composition of three-dimensional objects, and you can reuse them multiple times throughout your design. If you come from Unity background, this is called prefab essentially in Unity. So this is Delphi frames, Unity prefab, Castle Game Engine designs, and you can use it. Okay. I wanted to mention the Delphi versions that we support. We support everything from Delphi 10.2.1 as for desktops. For mobile, we have a bit stricter requirements, 10.4, and of course we recommend latest Delphi stable, 11.3, and of course we have tested with latest Delphi 12 beta, which is a secret, right? Don't tell anyone. And of course we support Delphi Community Edition. We actually specifically test Delphi Community Edition's releases because we know that a lot of users rely on it, so you can use this free version of Delphi with some, of course, limits where you can use it, how you can use it, but you can use Delphi Community Edition with Castle Game Engine. Finally, we have something called UI scaling. Don't worry, that's the last slide. So, the point of it is that we have, like Ray was talking about how to scale application from high DPI. Like we have something called UI scaling, which basically means that if your application runs on a screen that is like 2 times larger, then we can just scale your user interface to be 2 times larger. But what if your application runs on a screen that is like larger, but also has a different aspect ratio, like it's more rectangular or more square, okay? So our approach follows, this is very much like Unity UI scaling. The idea is that, first of all, you use anchors. So for everything, you must be certain whether it's anchored to the bottom right, top left corner, or something like this. And then you set something like UI scaling parameters in the XML file. Let me just, this file looks like this, okay? And what it tells the engine to kind of pretend for you that the screen has a size of 2600 and the height 900. It's just pretending. Of course, this actual screen size may be different, but the engine will like pretend for you. When you specify user interface coordinates, the engine will pretend for you that you actually work with exactly this window size, except if the aspect ratio of your actual window is different. So it may be actually, maybe what you will actually like see from your code will be more like, 2600 by 1000 or 1100, yeah? But it will never be, for example, like 3000 by 2000, yeah? No, because one of those dimensions will always match either your desired width or your desired height. Now it's all written in the documentation how to configure it. The point is that this is a very efficient way to make cross-platform application that work with any screen size. So you can run it on Android that can have widely different screen sizes in pixels, not to mention wildly different screen sizes in reality, physical screen sizes. And the same goes for the PC and so on. So your games can just look the same everywhere. And that's it. Thank you very much. There's a link to the project that I have been showing yesterday. You can download them from here. We will also distribute those slides to you. That's it. Thank you. Thank you very much. If you have any questions. Go on.
Can copy the logics.
Yeah.
How? when I import these components in another project, I will...
So you mean if you actually want to share those components between a few projects, yeah? Yeah, so the way to do, okay, yeah, because I said that they are specific to the project, but the way to actually like escape from this and have them not specific to the project is actually kind of trivial, because what you can do is in your particular examples, you can specify, I'm getting somewhere, let me just open a minute, okay? So what happened here is that we said that this component, it actually uses the editor units called castle lines and castle polygon. And those components, they are actually shared by other projects. And how did we do it? We just specified inside the compiler options a path that goes just outside of your project. And that's as simple as that. Of course, you could specify here something, you know, absolute, but then it will only work on you. But if you do it like this, then it will work for everybody. Yeah, so that's kind of a dummy way how you can share them between multiple projects. You don't need to do anything more. Right. Right, thank you. All right, thank you very much.